This is Engineer Faisal Ijaz. Hope you will be fine. In this channel, I prepared detailed lectures for chemical engineers and also for associate engineers. In this channel, you will find playlists of different engineering subjects which will help you in your study, in your interviews, and also during your professional industrial life. So subscribe my channel for more videos. Here I will present very important points of rotameter device. Hope after this lecture you do not need to search more data about rotameter. So rotameter is a device which is used in chemical and related industries. The purpose is to measure the flow rate and average velocity of the flowing fluid in the pipes. So a rotameter is a simple equipment which consists on a tapered tube and a float. In this diagram you can observe both tapered tube and a float. You can see the wall of a tube is not in straight line. That wall is inclined at some angle. So due to this reason, that tube is called a tapered tube. You can see the float location in the tube. So that float is placed inside this tube. So this arrangement can be connected with a pipeline with the help of flanged connections. So a rotameter always installed vertically and a scale is provided on the tube to read the values of flow rate. Working principle of rotameter. According to first point, when the fluid is not flowing in the pipeline, then the float rests at the bottom of rotameter. It's mean that flow stay at bottom when fluid is not flowing in the pipeline. According to second point, when fluid starts flowing in a pipeline, then the direction of flow of the fluid will be parallel to the y-axis of the rotameter tube. According to third point, when a fluid flow in the pipeline, then float will also move from bottom to the center of that rotameter tube along with the fluid. Now I tell you about float working chemistry, that how it deals with the fluid around it. So two types of forces are involved in this process. The first one is drag force. So what is drag force? Drag means by using force to move forward an object. So here flowing fluid in the pipeline in upward direction provide drag force which move float in forward direction. So in this diagram you can observe the flowing fluid with the help of blue arrow which moves that float in the upward direction in this tapered rotameter. Now concentrate on second point, which is downward force which applied on a float. Before this we talk about upward force which is drag force. So when drag force applied on the float, at the same time another force applied on that float. That force is a force of gravity, and you know the force of gravity produced due to the weight of a float. So now two forces are applying on the float. One force is a drag force which move float in upward direction, and the second force is the force of gravity which move float in a downward direction. When these both forces, drag force and force of gravity, are balanced, then the float moves to a particular location and it stay right there because of dynamic equilibrium. In this diagram you can see the force of gravity, which is indicated by a red arrow, and you can also observe another arrow indicating the force of drag. So these both forces are in equilibrium condition, so the float is staying here. In this diagram you can observe the rotameter tube, both sides black covers. So I tell you the reasons of these covers. So if the flow rate of fluid flowing through the rotameter is very high, then it is possible that float may exit from the rotameter tube with the fluid. So these net covers attached to either sides of rotameter to ensure that float does not get carried away in the pipeline. If due to high flow rates of fluid in the pipeline, the float may go into pipes, so it may create problems of blockage, and malfunctioning may also be due to the flanges to get weakened, and the liquids may start showering at the site of rupture. In this diagram I will tell you those factors which influences the rotameter. So the first one is fluid density, fluid viscosity, and also float density may include it. So the second one is flow rate of the fluid, and the third one is float size, float weight, and also float material, and the last one are outlet pressure and gas temperature and gas pressure, and also liquid temperature and liquid pressure may be in these factors. Now I will briefly tell you about the rotameter types. The first one is glass tube flow meter, the second one is armored purge meter, and the third one is flanged armored rotameter. Here you can see a glass tube flow meter, or you can say it's a rotameter. So these type of rotameters are used in industries, in pilot plants. Pilot plants are used in researches. So these are also used in labs to measure flow rates of both liquids and gases. The second type of rotameter is armored purge meter. It is useful for low flow rates, for high pressure, and for corrosion applications. The third type of rotameter is flange armored rotameter. It is used for automated system and also for high pressure application. You can observe these type of rotameters in this diagram. Advantages of rotameter. The first one is it is simple to install. The second one is it is easy and cheap to maintain. The third one is it has a linear scale over large ranges of flow rates may be measured. The fourth one is the pressure drop across the float is constant. The fifth one is hence the pressure loss due to the float itself is quite small. And the last one is these are very versatile. Their use can be changed for different systems. Disadvantages of rotameter. The first one is float would fall and just stick to the rotameter. So if opaque fluid is used, then the scale is not properly visible. It may cause misreading the meter. So the third one is it cannot be installed in a horizontal position, and the last one is if the flow rate of fluid is very high, then glass tubes may be subjected to breakage.